I'm back from the past. It's been a long time. Alright, guys. We're going to try this out. Oh, yeah. First things first, I do not own this PowerPoint, but I will be using it. I cannot see my face in the corner anymore when I record. I do not like this at all. So, today we're going to talk about 6.1. We're going to look at discrete random variables. We're going to look at finding the probability event, histogram, interpreting expected value, and standard deviation. Alright. First things first, a probability model is when you take all the possible outcomes and then you find out the likelihood of each of those outcomes. So you find, we've done this before in class. It's what you're looking at, what's the probability of it. Let's do an example. Let's say I'm going to toss a coin in the air 3 times. Oh, let's do this. Oh, too far. Too far. You guys miss me struggling around probably. We're going to denote X as our success. Okay? So now let's think about our possible outcomes. If X equals 0, what does that mean? Well, it means we flipped tails, 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 because X is number of heads. So the probability of doing that is 1/2 times 1/2 times 1/2. If it's a fair coin, which I hope it is. Right? What else is... What if X equals 1? What's that look like? Well, it means you could add tails, tails, heads. Tails, heads, tails. Heads, tails, tails. So there's 3 possibilities, right? Each of these is an 1/8. Because it's 1/2 times 1/2 times 1/2. So you had this, or this, or this. So I'm going to add these up. You get 3/8. Now wait a second though. What if X equaled 2? That means I had tails, heads, heads. Heads, tails, heads. Or heads, heads, tails. That's my sample space. That will also be 3/8. Same as over here. What's X equal 3 mean? It means I had 3 heads. I was a hydra. Ha! Ha! So it's 1/8. Alright? So I'm going to take that information and I'm going to put it into my probability model. Let's see how close I was. Yeah. I did it! Oh, jeez. Yeah. Alright? We did it. Same thing that happened over here. Pop, 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 pop. But now I'm going to put them into this table. My X values, my probabilities. Yar, nar. Now, get out of your face. Face the facts. Face. Where can I put this? Aha! Aha! Now I'm looking from above. Alright. So now, a random variable is when we want is a numerical value that describes the outcomes of a chance process, like flipping a coin. We took it, and we turned it into a variable. The probability distribution gives the possible variable outcomes plus the probabilities that they occur. Look at this. Look at this. Something of note here. Ah, gee golly, how do I clear this off? I did it. So again, we have our probability distribution. That's a tiny highlighter. It's our probability distribution, right? We had one before. Big thing is, every probability has to be between 0 and 1. And the sum of all probabilities has to add up to 1. We've talked about this before. Did before with that coin flip. Yar, did. 1/8 plus 3/8 plus 3/8 plus 1/8. It's 1. Okay? Whoa. I'm still learning again, guys. Alright. Awesome. All right. So in chapter 1, we talked about, we analyzed the shape of a distribution curve, right? Skewed left, skewed right, no skewed, non-skewed, no skewed, unskewed. Same thing works with probability distributions. Okay? So let's look at this beast right here. We have a probability distribution about Apgar score. It's kind of like what your baby's shaped like. So 1 has a very low probability, 9 has a high probability. Do you guys remember how we would explain this? Well, it'd be skewed left with a peak at 9. Okay? Means 9 was the most common by probability, and there's some on the left-hand side that are pulling the average that way. So let's look at this beast. Let's say you're doing Jeep tours offers. Again, this is from the book Practice of Statistics, some edition, 6th edition. So Pete's taking money randomly. This is a crazy way to run a tour. He's just randomly collecting money from people. Be like, you have a 5% chance of paying $900. Well, you have a 15% chance of paying $300. So here we have our X, a random variable, and this is our probability distribution. There's a 15% chance of $300 being collected, 5% of $900. Cool. This is what your histogram will look like. You can see at 300, we graph up to, whoa, wowee. We go all the way up to 0.15. I need to shrink that. At 450, we go up to 0.25. All right, I'm not going to spend a lot of time on this. I just wanted to color in these boxes. Makes sense? That's all there is to it, guys. Make sure you label. Make sure you use consistent intervals. Thank you. Oh, describe the shape, though. This shape would be roughly symmetric. Peaks at the middle, about equal on both sides. With one peak at 600. There's definitely a peak there. This is a mess, guys. I apologize. Oh, my face is gone. All right. So the mean. Now let's talk about how to find the mean of these, okay? How to find the expected value. In statistics, we call it the expected value because it's what you expect to get out of that situation. We'll talk about that more when we do this. But to do this, we find what's called a weighted average. All right, and this is a fancy formula. So if I have my probability table, right? My probability table. To find the expected value, the average, this is the formula. What I'm doing is I'm taking my X and I'm timesing it. Oh, cool, use the same color, Mr. Twill here. My X and timesing by the probability, and I'm adding my X times this probability. I'm adding the X times this probability until I get my E of X. That's the formula they'll probably give you on the test. We'll do some work on this. Don't you worry. Pause if you need to. Write this down. It's easier than what it looks like. Alright, let's talk about what that means. Yeah. So let's take a look at this. Pete's distribution. This was the money one, right? He's collecting money at random from his crazy business. And the average was $562.50 collected. Okay? Now think about mean this way. Mean is the balance point of distribution. So if I were to make a fulcrum here, put everything on this side on a scale, everything on this side on a scale, it will balance out. Now, if I were to verbalize this, if we randomly select many Jeep tours, Pete will make about $562.50 per trip average. So you can't say, we expect this to happen, because for one trial, there's sampling variability, right? You always have to include, for many, many, we would expect this much on average, okay? Many, many is important. One person wins the lottery one time, it's way away from their expected value. But if they played the lottery enough, they return to the norm. Okay, they lose their money is what I'm saying. So I'd be a teacher, never have any. We're going back to the baby problem. The APGAR score for the newborn baby. So let's find the expected APGAR score of a new baby. Little baby. Look how happy they look. So, I'm going to take my x and times it by the probability, because it's x. It's the sum of x pi, right? So I'm going to do 0 times 0.001. I want to add my x times probability. 1 times 0.006. Plus I'm going to take my x times that. Plus 2 times 0.007. Plus dot, dot, dot. My last one's going to be 10. It's 0.053. And when I add those all up, I have it written down. I did it. Swear to Bob. I got 8.128. Okay, so that's my expected APGAR score given many, 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 many little babies. Okay. By the way, the ellipses mean I did 3, 4, 5, 6, 7, 8, 9. Okay. Let's see if the book concludes. Yeah, they did the same thing. Pow, 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 pow. So if I were to put this in a sentence and interpret, I would say if many, many newborns are randomly selected, their average APGAR score will be about 8.128. I got 2 minutes. Now, we know how to find the center. We also have to be able to find the standard deviation and variance of the discrete random variables as well. So now, in order to do that, I gotta hurry. I only got 15 minutes per video. Oh, great highlighting color. So there's my probability chart. This is the formula. That's variance. This is standard deviation. Pause it and write that down. I'll go over what it means in a second. That's disgusting on there. I'll delete that. Alright. But this is very similar to your standard deviation we found before. We're taking our value, subtracting the mean, squaring it, but now we're weighting it, so we're timesing it by the probability that it occurred. Gee golly, what was that? I got 1 minute and 30 seconds. Alright. Cool. So let's do that APGAR score again. Let's go. Alright. So I'm going to do my mean, or my value, minus my mean, which was 8.128. Square it and times it by the probability. I'm going to add 1 minus my mean squared times the probability. I'm going to keep going until I get to the end of 10 minus 1, 2, 8 squared times the probability. Okay, when I do that, I got to check for time. Alright, so I do that all the way to 10. I get 2.066, which is my variance. Square root it to find my standard deviation. Pause it, look at this, digest it. It's important. They did the same thing. They messed up, though. That's fine.